Question 6.5, solving equations involving rational expressions. Here are some steps that we'll follow to solve these equations. We want to determine the LCD, or the least common denominator, of all the denominators in the expression. So first, we'll want to multiply each term of the equation by that least common denominator. Then we can solve the equation, and then we may check our solution and exclude from your solution any value that would make the LCD equal to 0. So let's look at some examples here. So solve for x and check your solution. We are adding 1 over 3x plus 5 6, and this equation says it equals 2 over x. So first we want to figure out what would be the least common denominator. If I'm looking at these denominators when I'm adding, they have to be the same for me to add them. So in order to do that, I can see what is the least common denominator between 3x and 6. Well, this would be, for the numbers, 6 is the least common denominator. 3 times 2 equals 6. Okay. For the variables, x, the lowest term x is x to the first power. So x would be the least common denominator. If we combine the variable and the number together, we have 6x. So 6x is our least common denominator. So what we'll do is we'll multiply each term by the least common denominator, which is 6x. So if I do that here for each one, I would be left with 6x divided by 3x, and that would equal 2. 30x divided by 6, which would equal 5x. And 12x divided by x, which would equal 12. The x's would cancel. Next, I want to solve for x. So I'm going to subtract 2 from both sides. So now I'm left with 5x equals 10. Divide both sides by 5. X equals 2. Check my solution. If I replace a 2 in here, does it work? And yes, it does. I end up getting 6 over 6, which equals 1, and that is true. Let's try another one. Solve for y. Well, first, we need to figure out what's the least common denominator. The least common denominator is just the combination of multiplying these two denominators together. So we're going to multiply each term by y minus 5 times 3y minus 2. If I multiply over here, I can cancel out the y plus 5, and I'm left with 3y minus 2 times 3. Over here, I can cancel out the 3y minus 2, and I can multiply by 3y plus 15. So now I'm left with 3y plus 15 is equal to 9y minus 6. So let's solve for y by getting all of our variables on the left-hand side and all of our numbers on the right. So I add 6 plus 15 to get 21. I subtract 3 from 9 to get 6. Divide both sides by 6. I get 7 over 2. Or as a mixed number, it'd be the same as saying 3.5. So then we can check our solution to see, does 3.5 work, or does 7 over 2 actually work with the original problem we had here, right? 3 over y minus 5 and 3 over y minus 2. We can check it. It didn't, sorry, that next slide didn't show the checking it. So we can say if we replace the 7 over 2, we would replace that here, and we would say, would 7 over 2 plus 5, 3 divided by that, would be the same as 3 over 3 times 7 over 2 minus 2. Okay. And we would check it to see if that worked, and if it did, we would say, yes, that's true, and if it doesn't, we would say, no, that's not true. Here's a different example. We want to find the least common denominator, and in this case, what we're looking at is the x minus 5 and the 2x plus 10. Okay. If I simplify this further, I can divide both sides by 2. So I'm left with x2 times the quantity x plus 5. So we have 2 times the quantity x plus 5, 2 times the quantity x plus 5. It's being multiplied on both sides of our equation here, of our equal sign. And then I have my rational expression, 3 times x plus 5. Okay, minus 2 times the quantity x plus 5 times 1, which wouldn't, give us anything different, multiplying by 1, equals 2 times the quantity x plus 5 times the quantity 4 minus x over 2 times the quantity x plus 5. What do we notice is we can cancel a lot of this out. This 2 times x plus 5 would cancel out on the right-hand side of our equals. And so that's what remains here. And on the left-hand side, the x plus 5 cancels, and we're left with 2 times 3, which is 6, times negative 2 times x plus 5. And then we can combine our like terms and solve for x, and we end up with negative 8. We can check our work to make sure that negative 8 does work if we replace it for x. Last example here, we want to solve for a, and then we'll check our work to make sure that it does work. In this case, the denominators are both a minus 6. So what we're going to do is we're going to multiply every single term. Even though this looks like it's one term, it's 2, right? We have our rational expression here, our fraction, and our whole number. So we're going to multiply every single term by a minus 6, which is the least common denominator, just like we did in the last problem. A lot of the times these are going to cancel because the denominator is already listed here. So really you could look at this differently and say, well, which one doesn't have an a minus 6 in the denominator? And that's what I'm going to multiply by. And the only one that doesn't is this negative 5. So this first one doesn't change at all. I mean, they cancel, it ends up canceling out. And this last one here on the right also ends up canceling out. So we're left with 2 minus 5a plus 30, okay, equals, and then this cancels out, 2a minus 10. And when we distribute, remove parentheses, rearrange this for solving for a, we get 6. And we can check, does this work? If I replace 6 in with for my variable, would this work? And it does not work, because if I subtract 6 minus 6, I get a 0. And we can't have a 0 in the denominator, it's undefined. So there are examples where we get a solution and it doesn't work, and it doesn't mean that you made a mistake.